Mhm. Yep.
Is that good enough?
Yep, definitely.
Cool. It's kind of presenting to be like, yes, that's great. You know, stress to be.
Yes, that's good.
I swear.
All right, everybody, we'll go ahead and get started. There we go. Turn that just a little bit. I wanted to start today by just pulling up the syllabus and making sure we're all on the same page about what's coming up. I did get your exams graded, but I didn't get a chance to put the grades in. So you'll get them back Monday. But you're gonna want them in your Blackboard journals because people did well. So I will wait till I can do that. I'm pulling up our syllabus here. slowly but surely. There we go. All right, so just some reminders here. So exam 3 will be distributed next Friday, and then it'll be due the following Wednesday. Be thinking about your project. Your outline was technically due Monday, obviously, as per usual, just get it in when you get it in. But don't let that slip away from you because it'll take a little longer than you think to get everything done. After that, we'll have sort of a disjointed fourth part of the semester because there'll be a day that I'm presenting at a conference. There'll be Thanksgiving break. And then you will have our last day of class. You'll get exam 4. And then that'll be due the day you do your poster presentations, which is the following Friday. So decent amount of stuff coming up. And just wanted to make sure everybody was on the same page about it. All right, so today we're going to finish this lecture about how to mislead people with tables and charts. So let me go ahead and switch out our captions here. All righty. So we've been looking at lots of examples, and we've been talking a lot about the axes being off, right? And even on exam 2, you looked at that on one of the bar charts. And so, as we've said, I don't know how many times now, you need to include 0, right? So this one with the yellow header here is what was published. It is the average number of weekly hours of work on your main job for full-time employees. And basically, it makes it look like people in Germany, which is who they were interested in, work way more than anybody else in the European Union. And when you put a 0 in there, you realize, well, it's not actually that much more. We're talking about like a couple hours a week here, right? We're not talking about 40 versus 30. We're talking like 40 versus maybe 38, right? And so, you know, perhaps not as idyllic as they're trying to make it out to be. If you do have a line graph, you don't actually need 0. So a bar graph is telling you the absolute magnitude of the values associated with each category. So it needs to be proportional. And one of the things we're going to talk about later today is what's called the principle of proportional ink and how we think about representations on various bar graphs. Line graphs, you have a change in your dependent variable as your independent variable changes. So that's what you're focused in on. You're not so focused in on the overall absolute magnitude. You're like, how are these two things changing together? So here are some examples of when you should not have a 0, right? So this is the average annual global temperature in degrees Fahrenheit. And if you look at it over like from the 1800s, it doesn't look startling, right? It's like, whatever, looks pretty flat. But then if you start to focus in, and this is just a century, you can focus in even more, obviously, you start to see that it's going up and up and up. And that we know the ramifications of that, right? Ice melt is going to drastically affect us here, right? In Hampton Roads, coastal Virginia, Tidewater, whatever the heck you want to call it, right? There's a whole bunch of different names, but particularly like downtown Norfolk, areas of Pungo, they will kind of be gone, right? If we get much higher water levels. Same thing for places like New Orleans, there are already islands in the Atlantic and Pacific that are just disappearing. because of water level rise, right? Not to mention the other consequences like a Category 5 hurricane just hit Mexico yesterday, right? We are still in the window for hurricane season, but this is kind of late in hurricane season to get one that strong, right? So those have ramifications, the heat waves we saw here, but especially in places like Texas over the summer, right? And so to zoom in is actually more helpful here because we know that even changing by half a degree, much less a whole degree over the course of a century, and we're going up more rapidly now, is going to have a lot of ramifications. And it's hard to explain that to people who don't understand basic science, right? This is something you will see quite a bit where people are like, let's just put everything on one graph. And it'll make it easier, right? It just makes it more confusing and can be misleading, even unintentionally. So this is looking at thyroid cancer. And this the yellow bars indicate the incidence of thyroid cancer. The red bar is showing how much glyphosate has been applied out of 1,000 tons. And I don't even know what the unit is here, right? Like it's really hard to tell. So that might be overestimating how much is owned, right? They're trying to blame it on genetically engineered soy and corn crops. We don't know. And then I don't even know how helpful it is to look at a pre-1990 trend, right? Because we don't live in a pre-1990 world. And so this is just really confusing and be much more helpful as 4 distinct figures, right? What they're trying to do is say, oh, it's because of the GMOs that this is happening. And maybe that is part of it, right? Probably not the only part of it. And we need to have good research to show that. You also don't want to change scale midstream. And so this is something that, like, until I started teaching this class, I hadn't actually even seen. And so this graph looks fine. Like, okay, this is equal, right? There's a 0. Well, we start at 10, so maybe we should have started at 0, but you know, that's all right because it's a line graph. This is your income group by percentile. And then you get over to 90, and all of a sudden it's like time by length, right? Like now we have 99, and then we have 9, and then 99. I think what's trying to say is that it is the top, 1% that's really benefiting from economic growth. This is not a good way to do this, right? What you should do if you're going to do something like this is, go up to 99, right? And then make this part of below in second graph, right? Or even you can make a little like picture in picture, pop it out over here, right? Because this is just confusing and it makes it look like there's the same amount of space between 90 and 99 as there's between 99 and 99.9 and so on. You want to use labels on your axes. So this does have them. Woohoo, right? And it's really specific, which is helpful, right? So this is the percentage among the top 10 searches for various computer languages. However, like this makes it seem like the languages themselves are like more so somehow, right? It's like conflating 2 pieces of information, right? This would probably be a better bar graph, maybe with the languages on the bottom and the percentages over here. It just is like a really confusing linear graph that doesn't actually mean. This one is one of the ones that like because I look for examples, I search for examples, right? Every single site that has examples of bad graphs has this one on it. And it's because someone decided, let's invert it. So it's upside down, basically. And what they're trying to show is it's the number of murders committed with firearms. Right? And I think they were trying to show that the stand your ground law led to more murders, right? Or maybe they're not. Maybe they're trying to say this is a good thing. And look at it drop, but it didn't. And it's just really confusing. It also is like, it's a line graph, so you could have zoomed in more, right? Really, where it's varying between like 400 and 900. So this is like way too much ink. It's unnecessarily confusing. There's nothing that would have been lost. And in fact, a lot to be gained by flipping it over, right? I don't know. Someone decided this was a good idea. What's that? Probably. Yeah. So the principle of proportional ink I kind of alluded to before. And this is the idea that just like that photograph we just looked at, when a shaded region is used to represent a numerical value, the area of that shaded region should actually be directly proportional to the corresponding value. And as we've seen from a couple of our examples so far, like I think about the Girl Scout cookie one, right? Sometimes just by nature of labeling things or trying to make a graph cute, this doesn't always happen and it can be pretty misleading. Okay, so here is an example of the top 10 most read books in the world. And honestly, if you look at it from here up, it's a good graph, right? We're starting at a 0. There is a little bit of weirdness here, right? In terms of like expanding the scale. I did 500, 1,000, 1,500. Yeah, so that's fine. And then you have your categories, just kind of like I was suggesting on that other graph, right? That maybe the categories could go along the bottom for different books. But because they included the books under them, again, trying to be clever, right? Trying to be cutesy. It makes it look like it's that much more, right? And that perhaps the quotations from Chairman Mao Zedong is like not that far off from the Bible. When in fact, again, if we look here up, it's a huge difference, right? And it's in Harry Potter, Lord of the Rings, The Life of Alchemist is so popular. The Vinci Code of Twilight, like that, right? Saw a Instagram reel the other day that was talking about Twilight just being redneck in a really interesting perspective. So by a guy who was a redneck. So yeah, again, these people aren't intending to mislead, they're just tending to be cutesy, and that can lead to some issues. So just like that Florida one we just looked at, if the chart is filled and the areas represent values, the axis should go to 0. Now, if you're not going to fill it and just do a line graph, it doesn't have to. But you want this to actually represent the percentages, right? And so that becomes an issue when you are, again, only starting your axis at 28 instead of 0. Again, very compressed. Is making it look more dramatic than it actually is, right? We're only going from 36 to 31, right? But it looks much more dramatic. Bubble charts. Bubble charts are something that, again, I wasn't familiar with until I started teaching this course. So these use color and size to indicate different things and their proportions. You can use both vertical and horizontal positioning. So you can simultaneously show 4 attributes of data for each point, which sounds great, right? But it can be really difficult to judge the relative size of the bubbles, and it needs to be carefully labeled, especially if you're making your bubbles small. It can be really hard to read. So for example, this is the top 10 films by worldwide grosses. And so like the production budget is here. And then this is the year the film came out in. And then how big the bubble is. And this was obviously stopped in 2009 because we would have like Marvel movies on here and whatnot now, right? And so this will then indicate the year it came out. And then the color of the bubble tells you which movie it is. And again, yeah, we got a lot of info from one graph, but like, I don't know how meaningful this was in comparison to, you know, just doing a bar graph. Like, I know that they wanted to put on production budget as well. So you could see that, for example, Pirates at the World's End, which I think might have been the third or fourth Pirates movie, right? Had a pretty high production budget, 300 million, right? And then didn't make as much money as something like Titanic that had more of like a 200 million, although that's in 1997 dollars, we need to remember, right? So it's probably more today. And that's another one of the reasons why this one in particular is somewhat problematic, because if you're not adjusting for inflation, right, then this could be misleading. So again, it's a nice idea. You can get some good information from it, but it can be really hard to interpret, and you really have to like stare at it. But because they're just bubbles, people kind of think like, oh, get it, right? So yeah, again. Then you can get even more complicated, right? So these are per capita GDP by life expectancy, and then there are various countries in Africa, the Americas, Asia, Europe, and Oceania. Oceania is like Australia, the Philippines, that area of the Pacific. And so, yeah, we kind of see that, you know, unfortunately, due to the inequities between the global north and the global south, it maybe isn't surprising that unfortunately we see Africa with the lowest life expectancy and also the lowest GDP in a lot of cases, and that Oceania and the Americas and some European countries are more up here. But like, I don't know when any of these countries are, right? Looking at, there's no like, who's this, right? Which Oceania country is this bubble? Is this the US, right? I would assume so, but I don't know. Which European countries are hiding behind this other bubble, right? Not actually that helpful, even though, again, it's like, ooh, bubbles, pretty colors. And so we think that it's easy to interpret. All right, donut bar charts. And these are a little bit different than the ones that folks did the other day. The ones that folks made the other day for our election data are essentially just pie charts with a fancy hole in the middle. Donut bar charts basically are bar charts that go around in a circle. And again, not something I'd ever seen before I taught this class, but definitely something I've seen since as I pay more attention. The problem is because they're curved, they can kind of exaggerate the differences. And it can also conceal them because of the curvation. And again, it can look like, oh, it's a donut, so it's easy to read, right? And this is like arable, which I believe is like land you can plant stuff on and actually get stuff out of, land per capita, and it's hectares per person. And then again, different countries here, right? And so you can see we start with Australia. There's a lot of land in Australia, right? I don't know if it's actually all arable like they're saying it is, right? But, you know, so like this is 1.875 per person. And this is 0.625 per person. So this looks like Australia just has like a crazy amount more land, when really it's like maybe double what's available for other people, right? And granted, some of these don't have, I mean, you look at a place like New Zealand, it's an island, right? You can't like grow it unless you do the crazy stuff they did in Manhattan, where they as they built the skyscrapers, they put the displaced dirt and also some of the like metal and whatnot into the river. And that's part of Manhattan is on that rather than natural land. Again, weird things you learn, right? So again, just making things harder to interpret than they have to be. Again, it looks spiffier than a bar graph, but it's not actually telling me any more information than it. You also don't want to change the denominator. Make sure you're using, if you're using whole numbers, keep using whole numbers. If you're using fractions, keep using fractions. That also can be very unintentionally misleading as well. So again, wanted to be careful. 3D charts. These are things that people absolutely love. They love a good 3D chart because it looks so spiffy, right? Look how fancy. Look how eye-catching. Okay, I'm gonna like take a quick step and tell you all this story. So when I was in college, I was one of the editors of our weekly newspaper. We had a Marlin Chronicle, but we put it out weekly. And our previous treasurer, who had graduated, had horribly misspent our money, like way overspent, and we had no idea because they never reported to us that this was happening. So because of this, the student council who gave us the money was like, we're going to cap your budget, which would have made it hard for us to print, etc. And so we're like, oh, shoot. We need to get this money back so we can actually like operate. And we put together a PowerPoint with fancy charts like this and like pie charts and things like that. This was right around the time the movie version of Chicago had come out. So we were like giving the old razzle dazzle. And like they immediately after our PowerPoint was like, okay, you need if you're just trying to impress somebody, this stuff can sometimes work. But if you're trying to actually portray data correctly, maybe not. I mean, we were doing that. We were just like making it look fancier than it was, right? So the other problem with some of these 3D charts is that it can be BS because when you add a third axis in, it implies there's a third variable you're considering, right? So just like if we go back a couple slides, when we look at the bubbles, right? There are 3 things we're looking at here, right? We're looking at life expectancy, per capita, and then we're also looking at, well, actually 4, because we're looking at which continent it's on, but also the country, even though we don't have a reference to that. Right here, by adding in that 3D element, you're implying there's another variable you're looking at, but in fact, you're likely only looking at 2, as you typically would with a bar graph. Because the end caps appear to extend the bars. And the fact that those end caps have depth implies there's something else we're looking at. And the end caps are using the same amount of ink irrespective of bar length, right? And so that can be misleading. But the size of this upper face here, again, if we were to just calculate like surface area that we could see, depends on the length of the black bar, which is an issue because again, it's not necessarily accurately portraying things. You also will see people, and you see a little bit of this here too, but who use these like perspective things. So this is just a regular bar graph that someone decided would look cooler if at the 50% point they had a bend and then the bars went up, right? There's no actual change in anything at that point. It just looks fancier. But it does distort the differences between these bars, right? Like these 200s are the same, but because of the perspective, they don't quite look the same, right? And so again, maybe not intentionally, but it can be misleading. And that's part of the artistic principle of foreshortening, that the objects along the line of sight appear shorter than those that are perpendicular to the line of sight. And again, here it's not even a sharp angle, there's a curve, right? And so that's even more troublesome because it's harder to wrap your human brain around. We're not necessarily good at interpreting this kind of stuff. And I'm just gonna check and see who else may have signed on while I was chatting here. There we go. All right, and then pie charts. This was something that I found, again, really funny, because I don't mind a good pie chart, right? And I thought the ones you all made the other day were great. But everyone who is pointing out problematic charts on the internet just hates pie charts. They argue that they're hard to interpret. I think more often their problem is some of those ones we looked at the beginning of the lecture, right? Where they're actually often done incorrectly, where the pie chart is more than 100% and yet it's represented as if it's 100%. I think if you actually are showing the percentages of things like voting, a pie chart really makes sense, right? But you can make pie charts in 3D as well. It's a little feature you can click on in Excel, right? And that does make them even harder to read because, again, if you're thinking about sort of relative surface area, this is off from what it's meant to be. So again, this is something I pulled from one of these sites. Percentage of pie charts that do not show the data clearly. Percentage of pie charts that could be replaced by bar charts. Yes, you could. But again, I would argue if you're doing something that's adds up to 100%, a pie chart makes sense, right? Especially if you put the percentages on it and the wedges match up to that. Percentage of charts in this figure that are unnecessary. Percentage of donut charts that are bad as pie charts. This one actually put the percentage on. And then this is someone who points out some of the more problematic ones that they've seen, right? So this is a pie chart showing, I believe it's the percentage of the market for various tech companies. And so you've got like Apple, Amazon, Alphabet is Google. I don't know if people know that, but the parent company for Google is actually called Alphabet. Microsoft and Facebook, which I guess would be Meta now. And then here's every other company. Yes, this is ridiculous. This is not helpful, right? Honestly, to portray this data better, I would just make a table that shows their actual percentages just listed, right? Because that's going to be easier to wrap your head around. I get that. That is a bad pie chart, right? He thought this was a good one. So he thought that these 5 companies that are over here account for actually half of the market, but in fact, they're looking at the S&P 500, and they're not including all 500. They're only including 282 companies, so they could sort of make a false equivalency that makes it look like they have half of the market share. That's also weird, right? So he redid it here. And what it would look like if you actually included all 500, right? And like these get ridiculous. You could also do something like this, right? Where the top 5 have this percentage, the bottom 282 have this percentage, and here's the middle 213. Again, maybe show you something good there. Maybe you can make a line graph. And so I think that was really interesting to sort of think about things that initially look good, and then you look at the data behind them. And I guess that's like the big thing that we want y'all to get from covering this particular chapter is you're gonna run into these, right? People on the internet love a good bar chart, pie chart, right? You're gonna see it on the news. You're gonna see it if you ever read a newspaper, right? And just anytime you see something depicted sort of graphically like this, figurally, just stop and look and sort of go, what data are they representing? And does it make sense how they did it, right? And again, some of those are easier to catch than others. So here are some examples of good data visualization. I'm going to be perfectly honest. These are all from papers I am a co-author on. And I wasn't trying to say like I'm good at it. These were just what I had most easily accessible to me, and I didn't want to like call out any other authors by showing bad ones. So this is from a paper I published with Kristen Heron at ODU and her students in 2015. This is again a table. I know it's not eye-catching and whatnot, but like in true scientific papers, a table is often the way to communicate this information most efficiently, right? And so here we have all the variables. We have the means and standard deviations of those variables. We have the Cronbach's alpha, which is the reliability, essentially how good and consistent the scale is for all the ones that it makes sense to have that. And then we have their correlations with each other, all in one table, nothing overlapping with anything else, right? Again, not fancy, but you have all the information you need right there. That's not to say that a good bar chart can't be helpful. So this is one where I showed, so dating myself here, before everybody had smartphones, back in the aughts, the early 2000s, we would pass up Palm Pilots for our studies. People would get an alert on the Palm Pilot and they'd have to answer questionnaires. And so what I looked at is I had a word stem, like let's say THI, right? And then what we were looking at is if they're more concerned about their body, are they more likely to finish that with thin, right? And so I was looking at how much time it took them to answer in milliseconds. And then there were words related to appearance and words were not related to appearance. And in particular, I was able to classify, I had a scale in this study that gave you whether they met criteria for an eating disorder or not. And so what you see is for eating disorder folks, when there were appearance related words, it took them longer. We thought they'd be faster because they're used to like processing those words and thinking about that stuff a lot. But in fact, it's not that much. These are milliseconds, right? But this is meaningful in terms of reaction time in that literature, that they actually were slower than people without an eating disorder diagnosis. And those without an eating disorder diagnosis were actually significantly faster on the appearance-related words than the non-appearance related words. And that's what these little bars up here tell us are the ones that there's a significant difference in between. So again, really interesting, one shot, try to be as clear as possible. Sometimes a line graph is more helpful than others. So this is from my dissertation. Yeah, I had to look at the date. And so we were looking at people's body dissatisfaction in the moment. And we were looking at when they compared themselves to someone they thought looked better than them. That's called an upward comparison. Versus someone else, someone they thought was equally attractive or someone they thought was less attractive than them. And then I'm always interested to see if holding feminist beliefs will be protective against body dissatisfaction. And what we found here is that at these other comparisons, you're comparing to someone you think is equally attractive to you, you're comparing to someone you think is less attractive than you, holding those feminist beliefs is helpful. You're going to feel less body dissatisfaction in that moment. But if you're making an upward comparison, if you're saying this person looks better than me, it does not matter. It's essentially the same data point, right? Sometimes your diagrams do get more complicated, and I actually am not that much of a fan of these, but this is just the best way to represent this type of analysis. So this is using something called structural equation modeling, where you essentially tell a computer program to look at all the relationships between these variables all at once. And then it'll tell you whether the relationships between them are significant or not. So in this case, media attitudes influenced internalizing that appearance ideal. but social influence from like your parents and your siblings and peers did not. You can also have other helpful figures that just illustrate parts of the experiment itself. So this was from a study that I collaborated on with a brilliant high school student who reached out to me and needed a mentor. And what she did was show people either Barbie or Tracy Turnblad from Hairspray dressed either modestly or in a bathing suit. And found some really cool results. And so including this in the paper showed people what the dolls actually look like. And then this one is my favorite I've ever done. This is from that same study with the reaction time to the word stems. They were like, we want you to show what that screen looked like. So initially I had submitted where I found like a stock footage of the Palm Pilot we used and then like put something on the screen. And they were like, no, you can't do that because that image is copywritten. We can't do that. So I made this diagram that is in a scholarly journal in MS Paint. Not even joking. I just vaguely drew what it looks like on these old Palm Pilots and then put in, so like here's the word stem, you know, the appearance related word is lean, but you know, is it lead, leak, leaf? Or we always had an other for them as well, in case the word they thought of is not on there. So yeah, this is in a publication. Not drew it in MS Paint. You just never know what you're going to be able to do or not do. But again, it shows people what the participants saw, and that's what the editors wanted us to do. Alrighty, so we'll finish early for today because that's everything for this lecture. And next week we'll start talking about understanding the people around you. Why do they do that? So have a great weekend and I'll see y'all on Monday. And again, on Monday, you'll for sure get your tests back. Your grades will be posted today. Thanks for signing on Zoom, everybody.